Today's presenters are from RF Solutions, Chris Godwin, Chief Technology Officer, and Lisa Jardine, Director of Communications. RF Solutions is an industry leader in the field of public safety communications. They partner with leading technology providers and manufacturers to deliver in-building life safety and wireless communications. We asked them to co-host this webinar with us as we work with them on several projects, some that were uniquely challenging, and they are always looking to identify opportunities for innovation by adopting new products and technology. In addition to public safety systems, the RFS portfolio includes in-building distributed antenna systems, cellular reinforcement, and two-way radio communication. And with that, I'll turn it over to Lisa to get us started. Welcome, Lisa.
Hi, John. Thanks so much. We're really excited by the opportunity to present today. Today we will cover the events leading up to the passing of National Public Safety Wireless Communication Codes, an overview of the NFPA 1221 and the IFC 510 codes, in-building public safety terminology, code adoption in several large cities in the US, challenges of obtaining requirements from local authorities having jurisdiction, AHJs, the differences in designing and installing public safety systems in new construction versus retrofits, IB-Wave 3D propagation modeling, pitfalls of improper design. Then we'll turn it over to STI to present on fire stopping materials, and we'll end with a Q&A. When I joined RF Solutions, I had no prior knowledge of in-building public safety systems or radio frequency technology. It was important to me to get up to speed as quickly as possible with the technology. But it was even more critical to understand the story behind why we have these systems in the first place. Fire alarm and sprinkler systems have been around since the mid to late 1800s, and the codes for those systems were some of the first fire and building codes adopted in this country. By comparison, model code language for in-building wireless public safety communications is relatively new, less than 10 years old. The seminal event that drives the code creation happens on September 11th, 2001. But before we discuss what happens that day, it's essential to know the type of communications firefighters relied upon before the code creation. In the 1980s, if you had a fire on the 32nd floor of a building, they'd search the building directory to find a telephone number of a company located on that floor. Once the firefighters arrived, they'd use that phone to call down to the chief officer command in the lobby. That was the only method of reliable communications available. From there, technology moved on to using a crossband repeater to extend the range of a firefighter's handheld radio by using a dual-band mobile or base radio located in the truck outside the building on fire. And then 9/11 happened, and 343 firefighters die in the towers. A 6-month examination by the New York Times found that the rescuers' ability to save themselves and others was hobbled by technical difficulties. When the firefighters needed to communicate, their radio system failed, just as it had in those same buildings 8 years earlier during the response to the 1993 bombing at the Trade Center. No other agency lost communications on September 11th as broadly or to such devastating effect as the fire department. After 9/11, it took 8 years for the International Code Council, the ICC, to introduce in-building requirements for public safety communications into the International Fire Code, IFC, in 2009. And then it only showed up in the appendix, which meant it was a recommendation available for adoption, not necessarily a requirement in the technical provisions of the code. Upon further modification, that language got moved to the technical provision of Chapter 5 of the IFC in 2012. The National Fire Protection Association requirements also followed similar timelines. A few months ago, I interviewed Deputy Assistant Chief Bronx Borough Commander Christopher Boyle, who currently serves as Chief of Tactical Communication for the FDNY, and one of the writers of the ARC System Fire Code in New York City. I asked him about the difference these codes have made for firefighters, and he said, when fighting a fire in a building without an ARC system, as soon as you went above the 15th floor, depending on the size of the building, it could happen even sooner, the firefighters you're trying to communicate with might as well be on the surface of the moon. You can't talk to them. Communication in a fire is critical, And if I can't find out what they have or what they're seeing, it's very frustrating. Having an ARC system is phenomenal. It took us from having no communication to being able to talk to whoever I need to speak with. Now I'm going to hand it off to Chris Godwin, our CTO. He'll lead us through the more technical aspects of the webinar.
Thank you, Lisa, and thank you, John. I want to note that even though we'll be reviewing codes with international applications, today's seminar will focus on code implementation within the United States. As Lisa mentioned, buildings have been equipped with fire alarm and sprinkler systems for over 150 years. At first, their installation was required in new or existing buildings by commercial insurance companies. Later, municipalities and then state governments enacted regulations and adopted standardized codes for building construction, which included requirements for these systems. The purpose, of course, was to make the buildings as safe as possible to protect human lives as well as property. What was lacking in all of this was attention to the lack of radio communications capabilities by first responders in those same buildings. They were equipped with handheld two-way radios, but those radios would not function well inside many buildings. A few municipalities did enact their own legislation requiring building owners to install radio systems, but there was no widespread call for this. As far as I know, the first city to mandate in-building wireless coverage was Burbank, California in 1991. Although today's codes are intended to meet the needs of first responders, including police, fire, and EMS, they have been developed and published with a background and an emphasis on firefighting services, as we now shall see. IFC 510 is part of the International Fire Code and comes from the International Code Council, or ICC, which develops comprehensive coordinated building codes. The ICC was formed in 1993 through the consolidation of 3 individual code organizations who had published uniform building codes starting in 1927. ICC then formed the IFC in 1994 by combining National Fire Prevention Code, Standard Fire Prevention Code, and the Uniform Fire Code into this new International Fire Code. IFC 510 began as a recommendation in the 2009 edition and became a model code in 2012, which allowed for its adoption as a complete code or statute. It has been adopted or is in use by 42 states plus the District of Columbia. It has a 3-year development cycle, and although the current code is the 2018 edition, many states still reference the 2012 or 2015 editions in their building codes. The IFC code states that the fire code official shall maintain a document providing the specific technical information and documents for the emergency responder radio coverage system. This document shall contain, but not be limited to, the various frequencies required, the location of radio sites, effective radiated power of radio sites, and other supporting technical information. The National Fire Protection Agency was formed in 1896 by a group of fire insurance underwriters who recognized that sprinkler systems were being installed in so many ways and with such different standards for pipe sizes and sprinkler spacing that their reliability was uncertain. The 20 original members consisted of fire underwriting organizations who had been calling for all buildings to have sprinkler systems ever since the Great Chicago Fire of 1871. They published their first sprinkler installation rules in 1896, and 2 years later, they published standards for the installation of fire alarm systems. In 1904, they opened their membership beyond the original stock fire insurance organizations. Within a year, they were joined by several organizations, including Factory Mutual Laboratories and the American Institute of Architects. Since then, NFPA has evolved into a nonprofit institution with 68,000 members from around the globe. When NFPA initially addressed in-building radio coverage for first responders in 2007, they included it in NFPA 72, National Fire Alarm and Signaling Code. In 2016, it was moved to NFPA 1221, Standards for Installation, Maintenance, and Use of Emergency Communication Systems, which was a better fit for this evolving technology. The 2019 edition is the final publication under NFPA 1221. Starting in 2022, it will be published by the newly created NFP 1225 Working Group, Standards for Emergency Services Communications. Hopefully, this will be its permanent home for a while. NFPA 1221 has a more comprehensive role for the AHJ, which is the local government entity that oversees these systems. I won't read through all the text on this slide, but it's a comparison of key code requirements that have evolved and are for the most part aligned between the IFC and NFPA codes and standards. The requirements listed here are pathway survivability, which is the requirement for cables to be protected from fire damage to a specific heat level for a certain amount of time. Typically, we use 2-hour rated pathways in these systems. Plenum rated coaxial cable is required. This means that the cable meets an NFPA standard certifying that it won't release toxic gases if exposed to fire. Any outdoor antennas must have additional protection against lightning strikes. This is for protection of the electronics equipment connected to those antennas. The donor antenna must have a certain level of isolation. That is, it must be located so that it is shielded from antennas inside the building. This is to prevent unwanted oscillation caused when the amplifier output has a path to feed back into its input. This is the same phenomenon experienced with an audio system when the microphone gets too close to the speakers. In this case, instead of a loud squeal, the result would be generation of wideband radio interference. Amplifiers have built-in protection against such oscillation, but this protection causes an amplifier to shut down and generate an alarm condition. A secondary power source provides battery backup for continued operation if AC power is lost during an emergency. Minimum signal strength and area coverage requirements are met by proper system design and verified by testing prescribed in the last item on this page. Signal RSSI levels are measured using a calibrated spectrum analyzer. DAQ, or delivered audio quality, is an additional standard which subjectively measures the quality and understandability of end-to-end speech through the system. Systems must provide alarm outputs for specific conditions or failures affecting their performance. These are tied into the building's fire alarm system for monitoring. There may also be a separate alarm annunciator adjacent to the main fire alarm panel. Equipment and batteries must be housed in cabinets which are NEMA 4 rated. This ensures integrity against water intrusion while firefighting is underway. NFPA has always required monitoring for malfunction of the donor antenna, as this is the operating link for an in-building system. The latest IFC code also requires monitoring of additional critical system components. To document that a system is operating properly and providing the required coverage, a comprehensive grid test is performed as part of the commissioning process. Each floor is divided into at least 20 equally sized grids, and signal level measurements are taken at the center of each grid, as well as at designated critical areas, and logged along with the associated DAQ in both directions. Calls are made to and from the dispatch center using portable radios borrowed from the first responder agencies whose systems are being amplified. Representatives from these agencies often attend the commissioning tests. After a system has been approved, its performance must be retested annually. Every industry has its own terminology, usually with a lot of abbreviations and TLAs or 3-letter acronyms. Here are common terms used in this presentation. You'll have this list in the presentation deck after the webinar, so I'll just mention a couple of them now. We will be discussing AHJs next. The terms ARCS, ARCS, DRC, and RAU are specific to a New York City application. The systems we are discussing today are generally known as Emergency Responder Radio Communication Systems, or ERRCS, which we might also refer to as ERCS. This has become an official designation for these systems. The authority having jurisdiction, or AHJ, articulates, interprets, and enforces the code that has been adopted by his or her city, town, or county. Each AHJ has specific needs. Every AHJ is part of a unique combination of agencies, including local or regional law enforcement, firefighting, and emergency medical services. These responders may be dispatched from varying locations and over radio systems using different technologies. Not all AHJs operate in the same way. Some have well-defined requirements. Others have little to no documentation regarding these requirements. Many times we help AHJs develop requirements and processes, especially in smaller towns who depend on volunteer fire departments to meet their needs. Sometimes finding the appropriate AHJ will take a fair amount of effort. The fire marshal is a good place to start. Most codes and statutes for buildings are set and enforced locally, not nationally. The local building inspector should incorporate these approvals into their inspection plans. Another challenge can be a rural area with a large public venue, such as an airport, stadium, shopping mall, or university. These often require coordination with additional first responders who are not under the jurisdiction of local administration, such as state police, county sheriffs, or even federal agencies. The IFC and NFPA typically update codes on a 3-year cycle. The frequency of change for local codes can vary. Processes and procedures can lag behind these changes in national codes. State and local jurisdictions adopt national codes through ordinances and set the rules and regulations for public safety in-building radio enhancement systems. These codes, in turn, reference standards that must be adhered to. For instance, IFC 510 makes many references to standards in the NFPA code. I mentioned earlier that 42 states plus DC have adopted various editions of IFC 510. There have been significant changes between editions, so it's very important to know which edition applies at a particular location and what, if any, changes or additions have been made. For instance, New York has adopted the 2015 edition, while California has adopted the 2018 edition. Florida has not adopted IFC 510, even though they have adopted ICC codes for construction, plumbing, mechanical standards, and for residential buildings. Instead, Florida has written their own code requiring all commercial buildings to have systems installed, if required, by January 1st, 2022, and for all residential buildings to meet a deadline of January 1st, 2025. As another example, the most recent IFC code adopted statewide in Texas is the 2006 edition, which was published before there was any reference to emergency responder radio systems. At the local level, however, you will find that San Antonio has adopted the 2015 code. Houston operates under the 2012 code, and Austin has their own modified version of the 2012 code. Let's look at examples of code locations in a couple of cities. Here's Boston, where the Boston Fire Department has written specific guidelines for all new buildings except 1- and 2-family dwellings. The diagram shows a typical ERRCS consisting of a donor antenna aimed at a first responder's tower site, a bidirectional amplifier, and an antenna network within the building. Both the Boston Police Department and the Boston Fire Department must approve every coverage enhancement system that is to be installed in the city. The requirements and process are well defined without being overly complex. Every system must have an approved 24/7 maintenance contract with a 2-hour response time. In Washington, D.C., the design of these systems has a similar architecture but more complexity. They have been required in all new buildings since January 2015. The AHJ here is the Office of Unified Communications, or OUC, which operates the District of Columbia 911 call center and dispatches police, fire, and emergency medical services. Every new building must provide coverage for simultaneous conversations on 29 pairs of frequencies. As you might expect, OUC has very comprehensive requirements for design and documentation of these systems and strict standards for their installation, operation, and maintenance. Every system is monitored continuously by OUC and must have the ability for OUC to remotely shut it down at any time. Okay, here's one more example, and as you will see, this one is a bit different. In New York City, every new high-rise building must have a system to support FDNY communications throughout. These are known as Auxiliary Radio Communication Systems, or ARCs. Unlike the previous examples, which follow national codes, these systems do not link back to a dispatcher, but instead provide two separate radio channels for on-site command and control. Every building has a designated fire command center where a dedicated radio console or DRC is installed. Upon arriving at a building, FDNY activates the ARC system from this console using their elevator control key. This activates the system, which then amplifies signals from firefighters' portable radios and retransmits them throughout the building. There are additional control capabilities available at the console. This concept is designed to support teams of firefighters operating simultaneously in a high-rise building. FirstNet is our first nationwide high-speed broadband wireless network dedicated to public safety. It is designed to be reliable and highly secure and offers innovative services for first responders using LTE technology. FirstNet provides services with enhanced priority on AT&T's nationwide cellular network and is augmented by the ongoing deployment of additional spectrum known as Band 14, a segment of the 700 megahertz band which is dedicated only to FirstNet. Specialized hardware and applications are available for first responders to use on FirstNet, with new innovative capabilities still being developed. Devices which are specifically approved for FirstNet service are activated by installing a proprietary FirstNet SIM card into the device. Service plans are usually adopted and administered by individual government agencies. Any proposed in-building enhancements of FirstNet services must be coordinated with AT&T as well as with the appropriate AHJ. Major renovation of an existing building usually requires upgrading various building systems to comply with current fire codes, and this includes providing radio coverage for first responders. It is important for such a system to be designed as early as possible in the planning process to take advantage of whatever pathways can be made available. The renovation may need to be more extensive than originally planned. For instance, to remove old copper telephone wiring so that there's a path where coaxial cable can be run. Finding or creating fire-rated pathways can be a significant challenge. In very dense residential buildings, you may find that antennas in the hallways are not able to meet coverage requirements, and therefore cable and antennas may need to be installed inside some of the apartments. When these systems are installed as an afterthought, the complexity increases tremendously. That's why it's also important to utilize accurate propagation modeling to ensure a successful installation. IB-Wave is an industry standard software for designing high quality, robust, and reliable in-building wireless networks. Starting with CAD plans for a building, our engineer creates a three-dimensional model of the building floor by floor. This includes the location and composition of interior and exterior walls, stairways, mechanical equipment rooms, vertical pathways, special building features, and so forth. The resulting model is then used to determine optimum placement of antennas and cabling to provide the required coverage. IB-Wave provides an accurate prediction of antenna signal radiation patterns and of radio signal attenuation through the building both horizontally and vertically from floor to floor. We can present a final optimal design with confidence that the system will perform as intended. A diagram of the proposed system along with their coverage predictions can be presented to the AHJ as part of the application process. Some of you may already have experience designing or deploying cellular enhancement systems, and I'd like to point out a few of the differences between cell systems and ERRCS. Both cellular enhancement and ERRCS can vary from simple designs to very complex systems, depending on the size of the facility and the number of carriers or frequencies involved. With a cellular system, connection to the signal source or system backbone is usually provided by the cellular carriers involved. With ERRCS, the system designer must determine the location of tower sites that will provide the best donor signal and then extrapolate or measure expected signal levels at the donor antenna. With ERRCS, the process is controlled by the local AHJ. Since cellular systems usually incorporate multiple carriers, there will be multiple contacts, each with their own approval process. There may also be a financial arrangement involving the owner of the building. ERRCS requires coverage throughout the building, including underground levels, parking garages, and the rooftop. Cellular systems often have a limited area of coverage to keep the price down, or may be installed in a commercial building to serve only one tenant, but not the entire building. ERRCS commissioning tests require coordination with the AHJ and with any local dispatch facilities or 911 centers who originate radio calls to first responders. Cellular testing is carried out using cell phones tethered to data gathering equipment. Monitoring and testing of cellular systems is again dependent on the various carriers involved, as well as the size of the system. ERRCS must adhere to published standards for regular monitoring and testing. Public safety in-building systems are not one size fits all. Each design has unique requirements, some of which are defined by the AHJ, and many of which vary with each individual building. There can be several other wireless systems in a building, and poor design of any one of those systems may result in interference with first responder communications. As you can see, there are very specific codes which must be followed. It's very important that the engineer designing an ERRCS system communicate with the AHJ to ensure that the final system will satisfy their requirements upon completion. Requirements may not be the same as they were in the last project. If a first responder agency is planning to upgrade their radio system to a newer technology or to change their dispatch operations, it's very important to take those plans into consideration to make sure that the commissioning tests are successful and that the AHJ grants approval in a timely manner. That concludes the AIA portion of our presentation. Now we'd like to introduce Dan DeSantis, New York City Territory Manager at Specified Technologies, Inc., STI Firestop. In his previous role as a project manager, Dan completed hundreds of commercial and industrial passive fire protection projects and specialized in shaft alternative protection. Dan is going to spend a few minutes before our Q&A session to tell you about STI's new innovative product, endothermic wrap. Welcome, Dan.
Okay, thanks, Chris, and special thank you to the whole RF Solutions team for the valuable knowledge that we all have gained through this webinar. We really appreciate your time today. As Chris mentioned, one of the considerations RF Solutions must make when outfitting a wireless communication system is pathway survivability. In simple terms, it is the ability for the system hardware to remain operational in the event of a fire. Survivability is perhaps the single most important aspect of an emergency responder system, because honestly, what good is a perfectly designed system without its ability to operate under extreme conditions like those of a building fire? Pathway survivability can be achieved in several ways. The traditional method involves a drywall contractor's services to construct fire-rated sheetrock enclosure around your system circuitry. In recognition of the market's need for an alternative, STI has developed a product called EWrap. The state-of-the-art technology is our proprietary shaft alternative, which is both lightweight and extremely flexible, yet capable of withstanding extreme temperatures in a building fire. EWrap absorbs heat in a predictable way to ensure the protected items remain in service and your pathway survivability requirements are met. We tested ERAP against some of the strictest standards known to the industry. ASTM E1725 is a fire test conducted by an independent third party to determine the efficacy of a shaft enclosure, specifically for the ability of a fire-resistant enclosure to inhibit thermal transmission to the electrical system components within. In order to meet this standard, the thermal sensors placed within the ERAP enclosure must not exceed an average temperature of 250 degrees across all sensors, and no more than 350 degrees Fahrenheit at any one sensor may be registered. ERAP uses a system of layering to achieve a desired hourly rating. 3 layers are required, each about a ½ inch thick, for conduits of 1 inch for 1 hour of fire resistance. For conduits sized 4 inches and down, 5 layers are required for a 2-hour fire resistant rating. For conduits greater than 4 inches, only 4 layers of ERAP are required to obtain 2 hours of rating. Intertek listing STI 120.01 is our proprietary third-party listing for conduit protection. This listing establishes the installation requirements necessary for a proper install of ERAP. The parameters set forth by this listing are crucial to the performance of the system at large and should not be deviated from. This listing also provides documentation which can be used for approval by the AHJ. So this illustration demonstrates the versatility of ERAP in the retrofit market. The clamshell is a popular installation method due to its space efficiency. Standoffs of 1.5 inches and sometimes less are seen along a cast-in-place concrete wall. This method, when properly installed, will provide a 2-hour rating, where traditional means of shaft enclosure may not be possible. For this system to work properly, the substrate must be rated cast-in-place concrete or CMU. Junction boxes play a crucial role in your building's wireless communication system and should be protected as such. Protecting your system's junction or repeater cabinets with ERAP is service-friendly. It can be removed and reinstalled fairly easily if troubleshooting or future upgrades are required. Metallic boxes installed in-line or as wall-mounted configurations can be wrapped, giving designers like RF Solutions the flexibility to route cables in the most efficient way possible. Every project presents its own set of conditions and no two are alike. Atypical conditions can be addressed via engineering judgments or EJs. EJs are custom project-specific engineering which come directly from our engineering services team here at STI. They are used to address conditions like the clamshell, as discussed earlier, as well as multiple conduits wrapped together and many others. These details will lay out the installation parameters for your site condition, but they will also serve as an important tool for your AHJ to understand how you plan on addressing conditions on the project. ERAP has been proven to be invaluable when it comes to pathway survivability for both new and retrofit applications. For more information, such as technical data or product data sheets, please visit stifirestop.com or contact your STI territory manager in your region. And with that, I'm going to turn it over to John for any questions that we may have.
Okay, thank you everyone for presenting. We do have some questions there, but if you've been on any of our webinars lately, you know that we like to give prizes for feedback on LinkedIn. So we're going to throw the next slide up there while we do our Q&A session, and that's going to give you a QR code. So if you hit that with your phone, you can give our speakers and our organization some feedback if you like the webinar, and you'll be entered for a chance to win one of those bags that we saw on the last slide there. So we do have a few questions that have come in. I guess we'll get started. This is it's a tough one to ask here. It's more of a comment, so maybe we can get a little discussion. I believe it's about the FirstNet being broadband now, and about the mission critical voice. Is this going to get more complicated, being that the cellular providers will be the licensee of the frequency band? Any comments on that?
Well, it definitely makes it more complicated. And I wanted to make sure that we mentioned FirstNet during this presentation, but there are thousands and thousands of users nationwide right now on FirstNet, and they operate both on AT&T's existing cellular network as well as this new band 14 that's been deployed in some areas. AT&T has hardened all of their cell sites and installed additional backup links and so forth to ensure much greater reliability than they had before. But yes, it is broadband. It looks like another cellular service basically, and everything has to go through AT&T. There are some areas where it's been adopted and required for in-building. There are others where where it's not required right now, but it looks a lot like cellular, except that it is subject to the requirements of NFPA and the IFC code. So this is quite a change, because right now AT&T normally just rides along any other cellular enhancement network, and not not a specific first responder network. So we're having to deal with that, because most of the products designed to enhance cellular systems are not of the commercial grade needed to meet NFPA code or IFC code. So it's in transition right now.
Okay, thank you. Christina, you have another question there?
Yeah, we have another one. Does FirstNet demand protection also?
Yes, it would be subject to the same requirements as any other emergency responder radio communication system.
All right. Dan, this might be a question for you. You mentioned the clamshell application on the concrete or the CMU wall. Can it also be used on a gypsum wall?
So the reason why it cannot be used on a gypsum wall is because how fire-rated gypsum walls work is that the outer layer is typically sacrificial. So if you have a 2-hour rated shaft wall or a 2-hour rated wall, for instance, the outermost layer is generally sacrificial to the fire, right? So if you're fastening directly onto a sacrificial layer of drywall, you're going to lose integrity of the system instantly, and therefore you have no protection. So no, the short answer is you cannot use a clamshell application on rated drywall.
Next question, how does ERAP pricing compare to 3M's current solution?
So we deal with distribution, as you know. We're dedicated to distribution, and we feel that the markets speak for themselves as far as price. So we encourage you to price out the market with your local distribution. Talk to your TMs; they can set you up with great distribution, and go from there. We can't really speak to price because we sell through distribution.
I guess this one is also for you, Dan. With retrofit applications, does ERAP meet the same requirements as shaft wall as far as like the FDNY is concerned?
It does, and because we've tested this to ASTM E1725, which is an extremely strict test, meaning that the average temperature of your system components can only reach 250 degrees Fahrenheit. It's extremely strict. So the FDNY has no problem with the use of ERAP on ARCs, FDNY ARCs. We've had approvals on many projects throughout Manhattan and the 5 boroughs. So yes, it is definitely a viable solution for anything as far as that goes.
We have another question here. Has the ERAP been used for any hospital projects?
Yes, as a matter of fact, STI and RF Solutions joined forces initially on a very high profile hospital in Manhattan, where approximately 900 linear feet of conduit required protection as a retrofit application. So there was a lot of ERAP involved due to large open spaces where shaft wall just was not a feasibility. And also I'll say that being that it was an active hospital, having a quiet application like ERAP, not having a contractor on site cutting and hanging drywall, is a lot less disturbing to your facility than other means.
All right. Does FirstNet have a backup? By this, I mean, what happens when FirstNet goes down? Are first responders back to their LMR network?
Well, as I mentioned, FirstNet has been hardened tremendously, but one of the issues still facing the industry. They're just in the process of developing a technology that would allow direct communication between the units. Similar to, basic walkie-talkies, just talking back and forth direct between units. Right now, they do not have that capability over the LTE. So most first responder agencies still have some other two-way radio systems and requirements, even though they've gone to FirstNet for a lot of their more advanced and broadband applications.
Is specific cable required within the protected conduit due to the 250-degree temperature permitted by testing?
That would probably be a question for Chris as far as what's required on the cabling aspect. I'm not exactly sure exactly which cables are required for these systems.
Yeah, the plenum rated coaxial cables that we normally install, half-inch coaxial cable, are the ones that have been passing the inspections with your ERAP wrapped around them.
Okay, there you go. Thank you, Chris.
I don't know the exact fire rating of them, but obviously without wrapping, they require some other type of 2-hour fire protection. So
yeah, that's a great point, Chris. So it often comes up is a plenum rated cable on its own sufficient for these applications? And we're finding that no, they're not. Additional enclosure is required on these systems, even when using a rated plenum cable.
That's correct.
There's no cable on the market that currently meets the standard to which ERAP is tested to, and therefore it is required.
All right. This one says, if the building is protected by an IBC compliant NFPA 13 sprinkler system, is there not a reduction in the fire rating of the protected conduit?
So that would fall under your survivability ratings of 2 and 3. So under the survivability rating of 2, it does require a sprinkler building in addition to a fire rated enclosure. So very seldomly do you see a survivability rating of 1 required on your project for this sort of thing. And in that case, a sprinkler would be sufficient enough. But for survivability ratings of 2 and 3, you will definitely need both. You will definitely, it's typically stipulated that in addition to a sprinkler system, you must have a shaft enclosure.
What product do you recommend using to seal the penetrations within the ERAP for conduit hangers or Kindorf?
Kindorf, okay. So our systems use LCI, which is our proprietary sealant, our Firestop sealant. It is an intumescent sealant. And if you notice on our systems, when you get a chance to look at them, that LCI is the product that's used commonly with all of our ERAP systems.
All right, well done, everyone. It looks like all of the questions have been asked at this point. And with that, I think we're going to wrap it up here. I'd like to thank RF Solutions again for their helping us to develop this presentation and for coming on and presenting, as well as our own Dan DeSantis. Thank you very much. Christina, do you have any closing words for the folks?
No, I just want to say thank you for everyone for logging on, and we'll be sending certificates and the recording and the slide deck out in 7 to 10 business days, and stay safe, everybody.